Hello and welcome to Education at SSBJ online video tutorials. We were in chapter motion of class 9th, right? Class 9th, that is CBSE. So we have a question here. In this video tutorial, we shall discuss on this question, and question reads: study the speed time graph of a body given below and answer the following questions. Where is the graph? Graph is this. Now carefully notice this graph. First thing which you have to find out is which physical quantity is there or plotted on y-axis as well as x-axis, right? This is the first thing you have to notice in the graph. So as you can see here, on y-axis speed is plotted, which means it starts from 0 here and then it is 1 means 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second, 5 meter per second and 6 meter per second. And on x-axis time is plotted, and you will find the motion is shown in a graph from O to A and then A to B and then B to C, right? It's a speed versus time graph, right? So remember this is the speed versus time graph. A body is moving in a certain speed, it increases its speed over a period of time, then the speed remains constant and then the speed reduces. This is what we come to know here. So there is change in velocity of the object which is going from O to A, right? After that, here at A, its velocity remains constant or speed remains constant. Here when I refer a speed or velocity, please take both physical quantities as a similar same physical quantity, because when the object, let's say object is moving on a straight path, right? If the object moves on a straight path, then a distance is always equal to displacement, which you have studied, right? So when distance is equal to displacement, then the velocity and speed will be equal, because speed is given by distance divided by time and velocity is given by displacement divided by time. So one more thing I want to tell you, why distance is equal to displacement? Displacement is the distance, shortest distance between the initial point and the final point. And what is the shortest distance? That is equal to distance. Distance is the actual path covered. Actual path covered. Okay. And what is the actual path covered? From here to straight here. And what is the shortest distance? Again, that itself is the shortest distance, because a body is moving in a straight line, right? As the time goes, its speed goes or velocity goes up, and then at this moment from A to B the velocity remains same, right? Look at this. If you are asked to plot the graph at 4 seconds, what is the velocity? 6. At 5 seconds, what is the velocity? Again 6. At 6 seconds, 7 seconds, 8 seconds, 9 seconds, 10 seconds, it's 6 only, right? And this, at this point, it is 6 meter per second, and then the velocity somewhere here it is coming down, and then it is coming down, as if like you apply a brake. Okay, you apply a brake here, and then the vehicle will slowly reduce its speed or velocity, and then it comes here, right? So point to be noted here, speed and velocity is same, because we are studying in this chapter only of those motion which are in linear fashion. Linear motion means what? Or rectilinear motion. Linear motion means motion on straight path. Okay, straight path, like this which I have told you. Right now, after understanding this graph, we shall see now what are the questions, right? And these are the questions. We shall take these questions one by one. The first question is, what type of motion is represented by OA? So in the graph, where is OA? O point is here and A is here. So the question is related to this particular line, not here. Okay, so we have to focus only on OA, and the question is, what type of motion is represented by OA? Right now, if you clearly observe that on y-axis you can take this as a speed, otherwise velocity, because as I said, both are same in this content, because we have to consider that a body is moving in a straight line. And what about this side on y-axis? It is time. Okay, as the time goes, velocity or the speed increases here. It is increasing. Okay, that's why the graph is moving straight. Okay, it's moving up. So in any of the graph, if you find, suppose it's a velocity and time, as the time moves, a velocity also will move, it will go straight. Okay, it need not be always a straight line. It can even be, see, if the time, a velocity and time is here, it can even be like this. This is also velocity is moving here. But what is the difference between this type of graph and this type of graph? Here a speed as well as velocity changes in equal amount. Changes in equal amount. What does it mean? It means for every second you will find change in velocity here equal. Means if it is 1 meter per second, for every second till here, there is equal change in velocity, and then only you will get a graph. If you can even plot, take an example of this speed, like a speed and then time, 1 second, 2 second, 3 second and 4 second. You can take this as 2 meter per second, and then 4 meter per second, and then 6 meter per second. So why I am taking these values? I take these values because there is equal change. 2 to 4, here 2 meter per second, 2 meter per second. Okay, and here 2 meter per second. If you draw the graph here, speed versus time or a velocity versus time, you will get a straight line. Okay, and remember, when the velocity changes, if a velocity changes in equal amount, in equal intervals of time, then okay, if velocity changes in equal amount in equal interval of time, then we say that motion is, or the vehicle is in uniform acceleration. Okay, it's an acceleration, remember. And what kind of acceleration? Uniform acceleration. So if the velocity changes in equal amount in equal intervals of time, then the motion is, so I'll write here uniform acceleration. Uniform acceleration. So please understand, therefore what does this motion from O to A represents? Uniform acceleration, right? We shall go for the next question, and next question reads, that is option B. What type of motion is represented by AB? This is the question. So AB is from here A to B, right? Now if you look at this time axis here, from 4 to 5, 6, 7, 8, 9, 10 till here, if you find a corresponding value of speed or velocity, you will find at A its velocity was 6 meter per second when the time was 4 seconds, right? Now here also anywhere you see, when the time was 5 seconds, velocity was again 6 meter per second, and so on till where? Till B, when the time is 10 seconds, velocity is again 6 meter per second, and therefore velocity is not changing. It's a constant velocity, or you can call this as constant speed, right? Either you can say constant velocity or constant speed. So this is the answer for option B. Next is, what type of motion is represented by BC? Now look at this BC. How different this BC is from OA. You will find in OA, you will find the velocity is increasing, whereas in BC velocity is decreasing, right? What is the initial velocity at B here when it is taken from B to C? 6 meter per second, and from 6 meter per second it is slowly coming to 5 meter per second, 4 meter per second. You can see the corresponding values here, okay, and then finally it comes to 0 here. So it's reduced, speed is reduced. And what does this straight line indicates? As I already told, in case of OA, if you get a straight line, this means a speed or velocity changes in equal amount. Then only you will get a straight line. Now here velocity increases. So what change is there in O and A? Increase in velocity. But what change is here? It is velocity is reduced. Okay, both are called as change. Here it is increased in velocity, increasing in velocity. Here it is velocity is reduced. Therefore, if velocity reduces in equal amount, then that kind of motion is called retardation. Please remember this, retardation. Okay, or it is even called negative acceleration. Please remember this. So if the velocity increases, it's a positive acceleration or simply an acceleration. If the velocity reduces in equal amount of time, it's again uniform acceleration, but it's negative here, right? And this is also called as deceleration. So all these three names are same. Either you can call this portion as retardation or negative acceleration or deceleration, because here velocity reduces. This is very important concept, right? So once again, OA represents uniform acceleration, uniform acceleration. It is not simply an acceleration, it is uniform because equal amount of velocity or speed changes. In the same way, this portion B to C is uniform deceleration or retardation. You can even call it as retardation. And what does this motion from A to B? A to B indicates constant speed. Okay, these three questions are over. Now let me give you a clue for these three questions. Okay, first one is, and then you have to tell me the answer of this. Find the acceleration of the body. What does acceleration means? Acceleration, if I can use the symbol A for acceleration, acceleration means change in velocity, change in velocity. As I said, velocity is equal to speed here divided by change in time, right? So what is the acceleration of the body? They are asking only acceleration, they are not asking a retardation. So we need not bother about the motion from B to C because it indicates retardation. And what is acceleration? Acceleration is here, O to A, and from O to A this is only acceleration. So we have to find out how much is the acceleration, and from O to A how much is the change in velocity? Change in velocity is equal to final velocity minus initial velocity. Now look at the graph and divided by time. Okay, change in time. Now look at the graph. How much is the final velocity when it is taken from O to A, and how much is the initial velocity? Then change in velocity you can easily find out, right? Time, you know how much. Time will be in terms of second, and change in velocity will be in terms of meter per second, and you get the answer here, acceleration in terms of meter per second square. I'm sure you are going to calculate this easily. Please let me know the answer of this. Okay. Now a clue for option E, calculate the retardation of the body. As I said, retardation indicates a reducing of speed or velocity. Okay, in this case, what is retardation? As I said, it's a retardation. Retardation is again an acceleration, but it is negative. Okay, so formula remains same. Acceleration is equal to change in velocity divided by change in time. Again, change in velocity is final velocity minus initial velocity divided by time. Now here final velocity changes. If you take a motion from here to here, what is the initial velocity? This is the initial velocity. And what is the final velocity? This one is the final velocity. Okay, now if you substitute here, you will get a minus value for acceleration. Alright, so this also you have to do from your side. And the last question F is how much distance covered when it is traveling from A to B I have already explained you in the previous videos how to find out the distance covered in velocity versus time graph. Okay, area of this will give you a distance covered. But please remember that this length and breadth, suppose if you take this as length, this is in meter per second, that unit you have to explain, and this one will be in second. So finally when you calculate the area here, it will come in terms of meters, because that is the distance is expressed in meters. I expect you that you will calculate this on your own before we make a video on this calculation and upload it. Okay, so this is work for you now, right? Thank you.